And the software part of the architecture is built in a very, very simple way with only 3 pieces inside it. Those 3 pieces are what we call demand, delivery, and supply. And they have very simple functions that are done. Demand. Demand works with the users. The users come along and say, I would like to look at the service catalogue. I would like to do certain things at this moment in time. Perhaps I want to add some more servers to my deployment, some more memory. But the ability to work with the workflows that are about the individual users coming into the system. The user then places a work order. That work order has to be delivered, delivery, hence my middle layer. And that is about instance management, building that instance of whatever it is. Whether that be a standard infrastructure as a service hosting environment, some type of LAMP environment or whatever, the right environment for Microsoft Exchange. But it might go further, because Microsoft Exchange, you might want Exchange loaded onto it. You might want Exchange configured on top of it and bring yourself up towards nearer software as a service. So delivery is about bringing together all the pieces that you requested out of the service catalogue. And then supply, well, that's the horrible job of dealing with all the horrible little assets and things underneath, the servers, the network, the storage, the hypervisors, the actual software packages themselves, but dealing with those resources. Now, key in understanding cloud is to see that they are 3 separate workflows. If you try to put those 3 workflows together as one workflow, I can only state, and we have seen it as a company, disaster will strike. Because it's too hard. The person who understands people and user portals does not understand how to configure an x86 Blade server. It's too much to ask of them. They can't build a top-to-bottom automation flow. It is beyond their ability. So you get a hierarchical system of user interaction, instance management, and resource management inside the solution. So you also get the roles of the individuals starting to appear. The user obviously buys from the self-service portal. The administrators work with the delivery and supply levels. They can also work at the demand level as well. And also there's another role. The other role is a very important role. This is the person who designs the services. The person who, upon being requested to construct a particular deployment of so many web servers, so many database servers, etc., actually puts it together and designs it and makes it available for the end users, makes it available into the service catalog. So there are different roles and different functions that exist. And this is obviously part of how, as you adopt cloud, the whole role of an IT department starts to change, because many of the people who would work to individual component levels before now drop into administrator and designer type of roles. We actually get an enrichment in terms of the employees involved in it. So, I'm a technologist, I had to do this, and the organisers have appealed to me not to use the more detailed version. But I just want to show you a little bit more about it. You can see demand, delivery, and supply, just like I had earlier. So my fundamental building blocks in my software about how it's done. But what you can now see is at the demand level, I can go and aggregate services and capabilities from other suppliers. I can go and get software as a service from another supplier. I might buy Microsoft BPOS, for example, for my customer through a single portal. So if you're serving companies inside a country, you're a service provider, and you're providing these capabilities, you can bring in things from third parties as well as the services you supply yourself. When you come down to delivery, you can do a variety of things in delivery as well, because obviously you can burst over when you've run out of capacity in your own facility, you've run into difficulties, you can burst over to some external public cloud capability. You can also, using a hybrid type approach, actually adopt much of the existing IT infrastructure. You can give it an interface to work to. I know it gets treated a little bit as a single tower at that moment in time, but this might be a great way to help you preserve existing investment, and in particular systems that you don't want to touch. You know, it's too dangerous to touch it, but you'd like it inside the environment, so you can bring it inside the whole world. And then you can get on there a private infrastructure capability there as well. So that's the basic picture. That's how HP builds our cloud services for our customers worldwide. So I said it was software. And I said it was all about the software, and the software being the key components, and I've illustrated the roles, the functions of those individual pieces of software. But actually those components are really quite interesting, because sat inside them there is a lot of capability inside that is represented through the software capability that's in there. And actually when I start to think about them, they themselves tell another story that is part of the whole that we need to bring together. And that story is a fundamental building block that we as a company have been talking about for about 2 years now, which is the whole idea of converged infrastructure. The whole idea that says, why are you coming out and looking at your infrastructure as individual components, as servers from best server maker, networks from best network maker, storage from best storage maker, and second best storage maker, and third. Why are you ending up with all these components individually put in, managing them separately? Why can't we start to bring that together? And so converged infrastructure is the story of starting to bring that together. Because now, if you can bring that infrastructure together, make it highly reusable, you can start to get a real set of business benefits. So what we start to do is we say, on the top of it, we have an infrastructure operating environment. It's a portal, it's an API. That portal and API sits and looks down at the infrastructure underneath, and it says, I understand you as a whole, not as parts. So instead of understanding you just as servers, network and storage, it understands you as the components needed to run NetWeaver. And it understands it's the right infrastructure to run NetWeaver, understands it as a whole at that moment. And obviously, once you do this, you're now starting to virtualize the environment. You need to be able to reconfigure and rebuild this. So the connectivity inside this environment becomes virtualized as well. You've now got to have a flexible way of connecting, reconnecting that infrastructure. So you get a flexible fabric connecting together the different components that are sat there as well. And in fact, what your whole capability appears like, it appears like a whole set of virtual resource pools that are sitting there available for you to use. And of course, once you start to bring this together and you start to collapse it together, you can think about all of the important aspects of energy management that goes on inside the environment. You can start to optimize the power through the whole system, not through just a single component at one time. You can really focus on running it as a whole, even going up to the data center level, thinking about it at the rack level as well, focusing on doing this. So this starts to build you a block, an appliance, for want of any better word. I'll call it a cloud appliance. I might get killed for that by some of the HP people, but a cloud appliance that brings the thing together, that gives you the capability. And that cloud appliance, of course, is manifested, and we sell one. We call it Blade System Matrix. It was referred to earlier. And that's very important because what you see is the pieces I've been talking about appearing. Because you see a service catalog, and if you can just vaguely see the service catalog on the left, you know it's the picture I showed you earlier. So the self-service portal, it runs out of the catalog. It runs using a set of resource pools. It's got its own service delivery. When you order, your deployment is made for you, automatic, through the automation capabilities inside. It also understands capacity management. So your IT infrastructure now has a capacity management. It's optimizing what is actually there through what you have for power, capability in the various servers. But very interestingly, there is a set of APIs. So something like this could be an island. It could be your private cloud island. But much more interesting, it can integrate into the environment. It can integrate into your service management systems, your change management systems, because the flows can go out and into the other systems, the practices that you have already. There's a basic charging mechanism. You saw the price earlier, and actually as you design an infrastructure, using the tools, the designer tools, you can actually cost how much this is going to be. It might be very frightening in some enterprises if customers actually saw, internal departments actually saw how much their IT costs. Might encourage them to be more economic in what they use. And other processes can be added as well. And one of those other processes is one that I'm going to come to in a moment. So, our basics of our Blade System matrix, a standard building component, a brick for us to use. Now, there's two ways in which integration of the hardware, the networks, the servers and the storage can actually be achieved inside a cloud solution. I've drawn for you there something called a cloud controller. That's essentially the middle layer that I spoke about earlier, working away. But it's got to work out how it's going to work with the network, the server and the storage. And as I said, it is quite possible to ask it to master how it works with each one, to configure from the cloud controller all the network details, all the server details and all the storage details. But if you think what I've just told you about converged infrastructure and the infrastructure operating environment that sits on the top, that can actually abstract all of those things down into, I would like an instance of this, please. I would like an instance of this particular three-level architecture. I would like this instance of 4 VMs or whatever you want. But actually being able to ask it at that level and not having to go through all of the details in. So what we believe is this infrastructure operating environment opens a very important API to the world and to the environments around. And one that we've worked on very heavily ourselves and use very much in deployments. Because instead of having the stack that we had at the beginning, which is great, private cloud inside your enterprise, we take away that top layer and we put the API on it. And then magic happens. What you can do is now collapse converged infrastructure into the supply function. So now it becomes part of the cloud stack. So the private cloud stack sits inside what would effectively be a public cloud stack or a service provider stack. And it simplifies the design processes throughout. And of course, you now get, your designer now can be a converged infrastructure designer. You also get a service level designer as well. You also now get administrators who administrate the right part of this infrastructure. So you're now beginning to set up components by jobs, by tasks, by functions that actually have a business purpose inside the IT department, rather different to the ones that is technology driven. You still have some technology driven ones, but you are now starting to run around the business processes that people know and the business processes that people have. And so this is quite revolutionary in what we can start to do in building public clouds. Martin talked earlier about SFR. SFR is built on this basis, but it carries you one step further.